Hello, this is all that you need to know about alcohols for the A-level specification, a bit far ahead. GCSE specification. Right, okay, so in organic chemistry, alcohols have the functional group OH at the end, OH. So, if we have a look at methanol, okay, remember that the alkanes go methane, ethane, propane and butane. It follows the same naming sequence. So one carbon is methanol. Okay, it looks like that, and it can be written as either of those. Okay, ethanol, 2 carbons, so it's C2H5OH, OH being the functional group, and you can see that OH is a feature in all of them. Ethanol is used in the alcoholic drinks industry, and it's also mixed with petrol for fuel. Propanol has 3 carbons, and again, OH is the functional group, and it can be written in either of those 2 ways. Okay, we tend to use that one, however, that one may prove useful later. Okay, and butanol, 4 carbons, and that's what it looks like. And again, OH being your functional group. Alcohols are important, they're flammable, they're used as solvents. For example, that's the smell that you get off marker pens. I would not encourage anybody to sniff a marker pen or a Sharpie. Other brand names are available. They're used in medicines, and they're also used in cosmetics such as your deodorants and your perfumes. Okay, ethanol is manufactured in 2 ways. It's either done by taking ethene, which is an alkene, and adding steam at a high temperature of 300 degrees Celsius and a high pressure of 60 atmospheres, where we're under 1 atmosphere of pressure, that's 60 times the amount. Okay, so you get ethene plus steam goes to ethanol. This is a continuous system. As long as you are feeding ethene and steam into the system, it will keep on making. Okay, so it can keep on running and requires not so much of a workforce. In a brewery, you're doing fermentation, and what you're doing is you're taking sugar from respiration in biology. We should know that as glucose with that formula. And you add yeast. Okay, yeast is part of the reaction, and it's around at 30 degrees, and we know that yeast operates best at 37 degrees, which is body temperature. Glucose produces ethanol and carbon dioxide under the fermentation process. It takes a while, okay, and it requires more workers in a brewery than this. It's a batch process, it's not a continuous process. Things that finish us off that you need to know about alcohols: they can combust as a fuel, okay? So you can burn them in oxygen, that either complete combustion, so it's making carbon dioxide and water, or incomplete combustion, where one of your products is carbon monoxide, because there's not enough oxygen. Okay, and there's an example of the next thing, which is reacting it with sodium. Now you can produce salts by adding sodium to any alcohol. So here, where we have got ethanol, okay, reacting with sodium, this is going to produce ethoxylic acid. Have I said that right? Yeah. Ethanoxic acid and hydrogen. Okay, so you're producing a salt by adding sodium. That is on the specification, interestingly. Yeah, okay. If you add water to it, it produces a solution. If you get to butanol, that is a longer chain, so it's not as soluble, so it's not as easy to do, but you can still do it. And last of all, if you oxidize, so if you add oxygen to it without burning it, you can make carboxylic acid. Any brewer will tell you that you need to make sure that everything's sterilised, and you need to make sure that you don't get excess oxygen in, because in the end, you are just going to end up making vinegar rather than making beer, which is not what you want, unless you want to make vinegar, of course. Okay, so here we have got, what's this one? There are 2 carbons, so we've got ethanol, okay, and we're adding an oxidising agent, okay. I've represented that with square brackets O. Of course, that could be O2 if you wanted to, but I'm just technically doing it the right way, okay. Carboxylic acids have got that functional group, COOH, okay. So essentially, if you add oxygen to beer and you leave it open, it'll turn into vinegar. Ha ha!